In this video we are going to solve a problem on buoyancy. So here the problem is an 8 cm side cube weighing 4 Newton is immersed in a liquid of relative density 0.75 contained in a rectangular tank of cross-sectional area 12 cm by 12 cm. If the tank contained liquid to a height of 6.4 cm before the immersion, determine the levels of bottom of the cube and the liquid surface. So here it is given that the cube is having 8 cm side and its weight is 4 newtons, and a liquid is in a container which is having sides of 12 cm by 12 cm, and the depth of the liquid in the container is 6.4 cm, and the specific gravity of the liquid is 0.75 is given in the problem. So what we need to find out here it is determine the levels of the bottom of the cube and the liquid surface after the immersion. So this is the problem, and after immersion of the cube the liquid level will rise, right? Here it is asked that to find out what is the bottom level of the cube H1 and what is the rise in water level from the bottom, that is H2. We need to find out in this problem, right? First thing is assume the body is floating in this liquid. So if it is floating, then the buoyancy force Fb must be equal to the weight of the body, that is equal to 4 Newton, and force of buoyancy is equal to specific weight of the liquid in the container multiplied with the volume of liquid displaced by the cube. So this is the force of buoyancy equation. Here we see the weight of the liquid, that is equal to, here the specific gravity is given, so specific gravity of the liquid into specific weight of water in newtons, 9810. This is the specific weight of the liquid, and we have to multiply this with the volume of the liquid displaced by the cube. So to find out that, we know the side, the bottom cross sectional area 8 centimeters, and this side is 8 centimeters. So the area of the cube in plan is equal to 8 into 8. So if I want this in meter, because it is in 9810 Newton per meter cube, divided with 100, this is the cross sectional area of the cube, and multiply this with the depth of immersion. The depth of immersion is, this is the depth of immersion, but we don't know this, so assume it is equal to x. Then the depth of immersion will become 8 minus x divided by 100 in meters. So this is the total force of buoyancy, and here it is given Fb equal to 4 Newton. So equate this is equal to 4. So if you solve this equation for x, I got the value of x is equal to minus 0.4949 meter. So here it is came that negative value. So already the liquid is at a height of 6.4 centimeter only. It means that the cube is totally sunk in the liquid, so it is submerged, and it touches the bottom finally, because the volume of the liquid displaced is not sufficient to lift the body up on the surface. So the problem now will become like this. So the body will sink and it touches the bottom, so then the liquid level will rise. So here the problem will become easier like this. So the rise of water level is must be equal to the volume of the fluid displayed. So the volume of the fluid displayed is equal to volume of the cube, that must be equal to the volume of water raised. So volume of the cube is equal to 8 cube, and the cross sectional area into the rise of water is equal to x, that must be multiplied with x. So x I got is 3.56 centimeters. So the height of water surface level from the bottom is equal to 6.4 plus x, that is equal to 9.95 centimeters. And they also wanted us to find out the bottom level of this. So here it is not required because the bottom is touch the bottom of the container. Thank you.